In Unit 5, we talked about quadratic functions and quadratic equations and how to solve those. In this unit, we're going to take a quadratic equation and graph it. So just like in the previous units, we're going to have inputs and outputs. And sometimes we call those inputs outputs, and I'm going to switch this to say x is the input and f of x is the output. Sometimes we'll write input output, sometimes we'll write x and f as x. F of x is a result of the value that you put in for x. So in this table, we're going to graph what is called the parent function. And once we know something about the parent function, that's going to help us graph every quadratic function. Some teachers call it the base function. I call it the parent function. In fact, all the Ozark teachers call it the parent function. So we're going to start with input values. We know this is a quadratic because it's x squared. So the first value that I'm going to input is 0. I'm going to actually try some positives and some negatives. So I'm going to put 0 kind of in the middle of my chart here. So if I put 0 in for x, the output is going to be whatever 0 squared is. And 0 squared is 0. So this means that I have a point on the graph at 0, 0. And I'm going to try some positives and some negatives. So I'll try 1. I'm going to go put 1 in for x. So the output is whatever 1 squared is, and 1 squared is 1. So I have a point at x1, y1. Then I want to try a value of 2 for x. So if the input is 2, the output is whatever 2 squared is. So the output is 4. So I go over 2, up 1, 2, 3, 4. We could keep putting values in for x. For instance, we might want to put 3, and if we did, the output would be 3 squared, which is 9. So I would have a point at 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's look at what happens with, you can see how this isn't linear. There's a rate of change of 1, but from here to here it is not 1. So this does not have a constant rate of change, so it can't be linear. Let's go put some negative values in. If I put negative 1 in for x, the output is whatever negative 1 squared is. And negative 1 squared is positive 1. So if the input is negative 1, the output is positive 1. If the input is negative 2, when you have negative 2 squared, that's the same thing as negative 2 times negative 2. And a negative times a negative is a negative times a negative is a positive. So we also have input negative 2, output positive 4. We also would have input negative 3, output positive 9. So you can see how this isn't the absolute value function because it doesn't have a constant rate of change on each side. So the graph is going to be curved and look something kind of like this. And this is a new word for us. The parent function, or any function that is an x squared, a quadratic, is not going to make a line, it's going to make a parabola. So there's some things we want to notice about the parabola. This point right here, that point is going to be called our vertex point. So in this parabola, the vertex is at 0, 0. And the definition of a vertex is the highest or lowest point on a parabola. So since this one is opening upward, the vertex is the lowest point. If it was a parabola that was upside down like this, the vertex would be the highest point. So there's the vertex of this parabola. Another thing that we want to talk about is the axis of symmetry. And the axis of symmetry is a vertical line that runs through the vertex. So this is my axis of symmetry. So we are going to label the axis of symmetry with an AOS for axis of symmetry, and it is a vertical line passing through the vertex. A vertical line passing through the vertex. So because this is a vertical line, we want to label it like a line. And so since every point on this line has x of 0, we say that the axis of symmetry for this one is x equals 0, because every point on the line is 0. The other thing we want to look at on this graph is the intercepts. Do we have any intercepts? Is it crossing or touching the x-axis anywhere? Yeah, at this point right here. Does it touch the y-axis anywhere? Yes, this point right here. So in this particular case, the x-intercept is 0, 0, and the y-intercept is the same thing, 0, 0. This one is called the parent function, and you can see how the vertex and the x and the y-intercepts are all the same. So what we're going to be doing in this unit, and you don't need to write this on your notes, but what we're going to be doing is taking this same graph and maybe moving it over so the vertex is up like this, or moving it all around, shifting it. We may stretch it out or compress it, but everything we do in this particular unit is going to be based off of this parent function.